All right, number one, the number of girls varied inversely as the number of boys and directly as the number of teachers. So we have a combined variation going on here. We have both an inverse and a direct variation. So we see inversely as boys and directly as teachers, and what's being varied as girls. So I think most of us have preferred the equal ratio technique for this, so I'm going to do it that way. If I start off with the statement, the number of girls varied, that's G sub 1 over G sub 2 equals. I'm going to make a fraction bar over here. And then when I see inversely as the number of boys, that just puts boys on top and bottom. And the fact that it says inversely means we invert the subscript. So we put a sub 1 here and a sub 2 there. And directly as the number of teachers, so teachers on top, teachers on bottom. And directly means the subscripts are in the same location. So that's how we set up the equal ratio technique. And then if I just figure out all these things, I'm looking for girls sub 1, girls sub 2. I'm looking for boys sub 1, boys sub 2, and T sub 1 and T sub 2. One of those 6 things I don't know, the other 5 things I do know. So if we take a look at this line here, that's the first number of each of the things. That's the subscript ones. So G sub 1 is 14 girls. B sub 1 is 28 boys. That goes in the bottom right there. And T sub 1 is 8 teachers. That goes up on top. So subscript 1, subscript 1, subscript 1 for those 3 things. And then it goes on to say how many boys were there when there were 98 girls and 10 teachers. So we don't know the final number of boys. The final number of girls is 98. The final number of teachers is 10. So it just creates that nice little proportion there. I can cross multiply immediately if I want to. I just happen to notice that 14 and 98 reduced down to 1 and 7. Or sorry, 2 and 7. 1 and 7 was right. 14 times 7 and 14 times 1. So that reduces, I would maybe do that much. So if I cross multiply now, I get 56 B sub 2 is equal to 280. By both sides by 56, we get B sub 2 is equal to 5 boys. So I would probably go that route on that problem. Number 2, another variation problem. This is a joint variation. And to vary jointly just means that it's a direct variation with more than one thing. Once again, if I look at spanners varied jointly, spanners, that's S sub 1 over S sub 2 equals fraction bar. When I see jointly, I'm looking at a direct variation with multiple objects, so ratchets and miters. So the ratchets sub 1 over ratchets sub 2, miter sub 1 over miter sub 2. It could be ratchets and miters and maybe nails and tires or whatever. It could give you a whole bunch of things, but in this case, one thing very jointly is 2 things. So subscript 1 over 2, subscript 1 over 2, subscript 1 over 2. Everything's direct variation. And just like the last problem, we're just going to create our proportion here. The first number of spanners, 756. The first number of ratchets, 7. The first number of miters, 9. So all the first stuff goes on top. The second number of spanners, 720. The second number of ratchets, we don't know. The second number of miters is 5. So fill in everything we know. Again, reducing if you feel like it. Calculators make life easy enough that we don't have to. So if I just cross multiply, 756 times 5 gets me 3,780 R sub 2, and 720 times 7 times 9 for this product gets me 45,360. Divide by 3780. We get 12. Anybody anybody wanting a different technique to do those, see me individually, but I would, again, equal ratio method in my opinion is the most efficient way to do those. That's the way I would do them. Number 3, the only way to mix a 47% antiseptic solution was to mix a 40% and a 50% solution. So we're mixing 40 and 50 to make 47. Okay, so our end result is 47. If you're not sure if you're mixing things together, the weak and the strong make something in between every single time. So I'm going to put some amount of 40% solution with some amount of 50% solution in order to get some amount of a 47% solution. Everything's antiseptic, so we're good there. We're trying to get 400 milliliters of the 47%, so we know the exact amount of this we want. We don't know either of these. So I'm going to put X in one box and 400 minus X in the other box. We need them to add up to 400. So if this is 100, 400 minus 100 is 300. So that makes 400. So whatever this final amount is, that final minus X and X will go in these boxes. Multiply straight down. 40 times X is 40X. 50 times 400 minus X is going to be 20,000 minus 50X. And 400 times 47, 18,800. So what's left to do then is to solve for X. If I move the 20,000 over here and subtract, I'm going to get negative 10X on the left-hand side is equal to negative 1,200. On the right-hand side, divide both sides by negative 10, that gets me X is equal to 120. Going back to my boxes up here, X is in the 40% box. It says how much of each should be used. I'm expecting to get an amount and of a percent. So 120 milliliters of 40% antiseptic. And then the other is going to be 400 minus 120, which is 280 milliliters of the 50% antiseptic. There's our two answers. So we're going to be mixing antiseptic on the test. 2 weak and 2 strong will make something in between. Should work similarly to this. The fact that we got nice pretty answers here, I'll probably make it so that nice pretty answers come out on the test. Number 4, a system of nonlinear equations, and x squareds match, y squareds match, numbers match, so elimination is legal. When elimination is legal, it's easy. Y squared minus y squared cancels, so we're ready to go immediately. X squared plus 3x squared is 4x squared. 25 plus 11 is 36. Divide by 4, we get x squared equals 9, which means x is equal to plus or minus 3. Make sure you don't forget the plus or minus. Anytime you have letter squared equals number, x equals plus or minus that number, or y equals plus or minus that number. We get 2 answers for x. X equals positive 3, x equals negative 3. Each case we need to figure out what y is. I'm going to go right here. X squared plus y squared is equal to 25, which is 9 plus y squared equals 25, which means y squared is equal to 16, which means y is equal to plus or minus 4. This x leads to both of those y's, so 3 comma 4 and 3 comma negative 4 off of that answer. When x equals negative 3, that means negative 3 in parentheses squared plus y squared is equal to 25. That just gives me 9 plus y squared equals 25. Exact same equation, so the exact same answers. So those answers are negative 3 paired with positive 4 and negative 3 paired with negative 4. Be careful that you get 4 answers. Plus or minus on each one creates 4 answers altogether. So be careful. Don't forget the plus minus. People forget the plus minus, only give me that answer. They lose 3/4 credit, so watch out. Number 5, a system of equations. We have 3 variables, 3 equations. In this manner, I'd prefer to use elimination to substitution, and I would probably get rid of z. I'd pair these two up. I'm going to double this. So negative 2z plus 2z is going to cancel. And when I multiply it, 2x plus x makes 3x. 6y plus y makes 7y. Negative 2z plus 2z cancels. 22 minus 7 equals 15. If I pair these two up, Again, getting rid of z. This needs to become negative 2z, so I'm going to multiply this by 2. 4x plus x is 5x. 4y plus y is 5y. Negative 2z plus 2z cancels. 12 minus 7 equals 5. The red equation, everything's 5. 5x, 5y, and 5, which is the same as x plus y equals 1. That's not a requirement to do that, but when you see stuff like that, it makes these problems tend to be easier. So x plus y equals 1, 3x plus 7y equals 15. I've gone from a system of 3 equations with 3 variables into a system of 2 equations with 2 variables. I'm going to solve this system for x and y. I want to know both x and y and come over here to figure out what z is. So, if I want to get rid of, let's say, x, if I take this equation by a negative 3 and combine these two equations together, 3x minus 3x cancels. 7y minus 3y makes 4y. 15 minus 3 makes 12. That gets me y equals 3. I know x plus y equals 1, so x plus 3 equals 1 because y equals 3. That means x equals negative 2. And now I know both y and x, so I come back, let's go here. X is negative 2, y is 3, plus 2z must equal negative 7. Negative 2 plus 3 makes 1. Move the 1 over and subtract, we get 2z is equal to negative 8. Divide, we get z is equal to negative 4. Once I get all 3 answers, then I write my answers in order triple. X first, y second, z last. Number 6, g of x equals 4x minus 2, domain set of reals, find g of a half. The only purpose of the domain here, the only reason that we care about the domain, is we need to verify that this number is in that domain. If it is, you're allowed to do it. If it isn't, you just put an empty set. So if this said d equals integers, 1/2 is an integer, it's immediately empty set. Since 1/2 is a real number, we can do it, and g of 1/2 just means you change x to a half. So 4 times 1/2 minus 2, that's 2 minus 2, which equals 0. So if you can do it, it's going to be that easy. If you can't do it, if this number does not match that domain, the answer would be empty set. In this case, the answer happens to be 0, which is not the same. Empty set is no answer. 0 is an answer. It's a numerical value. So, again, the only reason it's empty set is if this number does not belong to that set. Number 7, graph on a number line. It's a disjunction, so it's just basically graph both inequalities on the same number line. The first inequality, it has a negated inequality, so I'll rewrite it as x plus 5 is less than 4. Whatever it's not, it's going to be the other, so it's not greater than, it's not equal to, so it must be less than. If I move the 5 to the other side, I'm going to get x is less than negative 1. Over here, x minus 1 is greater than or equal to 1. Move the 1 over the other side, we're going to get x is greater than or equal to 2. So, domain's a set of real numbers, so I have to worry about open and closed circles and shading. So, x is less than negative 1, starts at negative 1 with an open circle because it's not equal. Reals means shade either left or right. Less than goes left, so I would shade off to the left. And make the arrow bold. For the red one, x is greater than or equal to 2. Greater than or equal to gets me a filled in circle at 2. Greater than goes to the right, so I'm shading off to the right like so. Make the arrow bold, and there you go. Number 8. Simplify a to the third to the x minus 1, b to the 5x over a squared times b to the 3x. First thing I'm going to focus on is the power to a power structure here. So, the outside power is x minus 1, the inside power is 3. The rule says I'm supposed to multiply inside times outside, distributive property required, so that's 3x minus 3. Everything else stays what it was, so b to the 5x stays b to the 5x, a squared stays a squared, b to the 3x stays b to the 3x. The next thing I'm going to do, once I deal with the power to a power situation, is I look for the same letter being multiplied on top or bottom. A times b, they're different, so I don't have to worry about that. If I did have a scenario where, let's say that's a and that's a, I'd have to add the powers, but since they're different, I don't do that. Final thing I look for is the same letter being divided by itself. That's happening with both a and b. And the rule tells me that I'm supposed to subtract the powers and put the answer where the higher, well, put the answer where the higher power is, but assume the top power is higher. So get rid of the fraction form at this point. So A, I take the top power 3x minus 3 and subtract the bottom power. For B, I take the top power 5x and subtract the bottom power 3x. And then I simplify each of those by combining like terms. So A, I'm going to get 3x minus 5. And for B, I'm going to get 2x. Like terms there, like terms there. And do what you can. We're looking for A to some power, B to some power for a final answer. Moving on to number 9, simplify. First thing I notice about this, and it's not a requirement to do this, but everything divides by 3. If you want to do that, you can. It'll make the numbers smaller. That's the advantage to doing it. The numbers aren't going to be that large to begin with, so it doesn't matter if you do it or not. But I do want fractions reduced as much as possible, so the reduction of fractions is a little simpler if you do that. Whether or not that happens on the test or not remains to be seen, but again, if it does, that's how you do it. Everything divides by 3. And the problem is the I in the denominator, we don't want that, so we're going to multiply both top and bottom by the conjugate. And the conjugate is just the same two objects, opposite sign. So the bottom gets multiplied by 2 plus 4i, the top also gets multiplied by 2 plus 4i. On top, I'm just going to FOIL. On the bottom, I'm just going to do first and last. And I get whatever I get. So on top, if I FOIL it, I times 2 is 2i. I times 4i is positive 4i squared. Negative 3 times 2 is negative 6. Negative 3 times 4i is negative 12i. On the bottom, 2 times 2 is 4. Negative 4i times positive 4i is negative 16i squared. So you should get a total of 6 products there. On top, FOIL. On the bottom, FL. First, last. The outer and inner products, 8i, negative 8i cancel, so ignore those. Just throw them out. What should happen each time is you should end up with an I squared on top and an I squared on bottom. That's not a coincidence. That's what happens on these problems. So positive 4i squared is negative 4. Negative 16i squared is positive 16. I squared simply changes the sign, makes a real number. So on top, the real numbers are negative 10. The imaginary numbers are negative 10i. And on the bottom, 4 plus 16 is 20. Final step here is reduction of fractions. Again, break it apart into pieces. So negative 10 over 20 minus 10 over 20i. That makes negative 1/2 minus 1/2i. Had I not done that whole reducing thing to begin with, just to show you the difference here, 3i minus 9 over 6 minus 12i, multiplied by 6 plus 12i. Same idea, same objects, opposite sides. FOIL, I'm going to get 18i. I'm going to get plus 36i squared. I'm going to get minus 54, and I'm going to get minus 108i. On the bottom, 6 times 6 is 36, and 12i and negative 12i make negative 144i squared. That's negative 36, that's positive 144. Negative 36 and negative 54 make negative 90. 18i minus 108i makes negative 90i. All that's over 180. That's negative 1/2, that's negative 1/2i. It's the same answer, just much smaller numbers when you do the divided by 3. Look for the possibility of reduction beforehand. It makes life easier. Number 10. We have a radical equation. The uglier radical is already isolated, so my first step would be to square both sides. So I square that and I square this. The square root of x minus 17 squared is just x minus 17. 17 minus the square root of x squared, I'm going to square the first object. I'm going to double the product of the two objects. And I'm going to square the second object. The two squares are always positive. The product is whatever sign is in the middle. So there's what we get. And by squaring both sides, one of the radicals disappeared, the other one sticks around. At this point, I want to get the radical isolated. I like a radical positive, so I'm going to move that over to the other side. If that was plus, I'd move the other stuff. I'll move the x and the 17 over to this side. So x moves over minus x, 17 moves over plus 17. And that moves over, so I get positive 34 square root of x is equal to 306, and the x is canceled. And once I get here, I divide both sides by 34. 34 into 306, I believe, is 9, just to be safe. 306 divided by 34 equals 9. All right, so the square root of x equals 9. And so the same thing happens. I got a square root equals something, so I squared both sides. I got a square root equals something, so I'm going to square both sides. That leaves me with positive x equals positive 81. That represents the only number in the world that could possibly be the right answer for the problem. The last step is to verify that it actually is the right answer. We're going to put the value 81 in place of all the x's up in the original equation. So 81 goes here and here. 81 minus 17 is 64. 17 is 17, and square root of x is square root of 81. Square root of 64 equals 8. Square root of 81 is 9. 17 minus 9 equals 8 is true. When we see true, we just circle the answer. So 81 is the right answer. If this were false, we would just throw that out and put an empty set for the final answer. Number 11, the two forces act on the point as shown. Find the resultant force. So let's focus first of all on the slanted vector. Make it blue. There we go. So the slanted vector, you have to establish a quadrant because the angle in the picture is alpha, a reference angle, not theta, the angle we're looking for necessarily. The vector we can see very clearly is going into the first quadrant. So in the first quadrant, the angle we care about, theta, equals the angle we have, alpha, so 65 degrees. So this blue vector is going to be 8 at an angle of 65 degrees. The other vector, that vector there, is going straight to the left. Now, when you have a non-slanted vector, it's going to have a specific angle measure. Straight to the right is 0 degrees, straight up is 90 degrees, straight left is 180 degrees, and straight down is 270 degrees. So it's going to be one of those four directions. In this case, straight left 180, so the vector there is going to be magnitude 5, angle 180. So job 1, take the picture, create a correct vector addition problem from the picture. Step 2, get it in rectangular form. 8 cosine 65 equals 8 sine 65 equals, that gives me for the blue vector, negative 4.50i plus 6.61j. For the red vector, I can do the cosine and sine stuff here, but notice it's going straight left, so that's straight left, negative 5i, and it's not going up or down, so plus 0j. The angle also does that for me. 5 cosine 180 is negative 5. Oh, you know what? I'm in radians, not degrees. Good thing I did that. Try fixing this here. Got to refigure the blue one then, because those numbers are going to be wrong. Do check that we're in degrees, not radians, before we start. So 8 cosine 65, 8 sine 65. So the blue vector is actually 3.38i and positive 7.25j. Should have noticed that to begin with, because of a negative I that would have been left and out when we're in the first quadrant. If I do 5 cosine 180 and 5 sine of 180, you'll see that negative 5 and the 0 that we were expecting happens. So negative 5i plus 0j. So to get the answer, we're simply going to add the vectors up in components. So the horizontal components, the vertical components create the horizontal component, vertical component vector. So negative 3.38 minus 5 is negative 1.62i. And 7.25 plus 0, of course, is 7.25. So that's the correct answer. That's going to get me worth half credit. So you get to that point, again, have it on your paper, like I've always said, put that on your paper. Make sure you get your half credit for having the right answer. Now the final thing we have to get the the polar form out of this. So r is going to be the square root of 1.62 squared plus 7.25 squared. Squaring always creates positives, so don't even write minus signs on this step. That gets me a magnitude of 7.43. Step 2, alpha equals the inverse tangent of the horizontal over the the vertical over the horizontal. Absolute value, so again, no negatives in this step either. 7.25 over 1.62. That'll equal some number. Inverse tan 7.25 divided by 1.62 comes out to 77.40 degrees. Step 3, we have established a quadrant. So I'm looking at my resultant vector here, and it's negative 1.62, positive 7.25, so it's going off in this direction. That's the second quadrant. In the second quadrant, theta is equal to 180 minus alpha. That comes out to 102.60 degrees. So magnitude 7.43, angle 102.60. That's full credit. Again, this is half credit. So give me at least there, give me your half credit, but then correctly transforming to polar form will get you full credit. Number 12, find P. Okay, we have an abstract equation, we have parentheses, so our first step is to get rid of parentheses. Be careful, x plus y is a binomial numerator on that, so when I distribute that t through, that t is going to multiply by both pieces. So j is just j. T times this whole term is going to be tx plus ty over p. T times that is going to be minus mt. So this multiplies by the top, over p is not affected by all that stuff. But again, tx and ty, not just tx. Then, once I get rid of the parentheses, getting rid of fractions is pretty straightforward. Times p is going to do the trick because that's the only fraction. P times j is pj. Tx plus ty over p is going to be tx plus ty. The p's cancel. And mt times p is going to be mpt. At this point it says to find p. There's p's in these two terms, so I'm going to move the mpt over here. So pj plus mpt is equal to tx plus ty. I take a p out. J plus mt is equal to tx plus ty. And then divide everything by j plus mt, so p is equal to tx plus ty over j plus mt. Parentheses, get rid of parentheses with distributive property, get rid of fractions, get every term down to just a simple level. Everything containing the letter you care about goes to one side, everything else goes on the other. Take the letter you care about out, divide by the stuff that's being multiplied by it. 13, use the relationship PV equals nRT. P is pressure, V is volume, N is number of moles, R is this number right here, and T is the temperature in degrees Kelvin. And all we have to do is substitute all those numbers in that we know. It says find the number of moles, so we don't know N. So everything else we should know, so it's just a matter of finding those numbers and putting them in the right location. So pressure is 7 atmospheres. Volume is 30 liters. That's PV. N is what we don't know. And then R is 0.0821. And T is 456 Kelvin. So this times this equals this times this times this. Don't forget that 0. I've seen people put 0.821, get the wrong answer, so it's 0.0821. At this point, it's just use a calculator to evaluate. So slide it over so we have room. 7 times 30, of course, is 210. 0.0821 times 456 is 37.4376. And to get N, we're going to take this divided by that. So 210 divided by, if I hit answer, that just divided by answer. Divided by answer just divides by the previous answer. You can also type in 37.4376. We get 5.61 moles. Remember that moles plural if it's bigger than 1, moles singular if it's less than 1. I'm not going to be that nitpicky, but just having good form on your answers is probably a good plan. Number 14, solving a quadratic equation. The easiest way to do this is with the quadratic formula. To get the quadratic formula to be usable, I have to get the 2x over here, descending order. So 3x squared plus 2x plus 5 is equal to 0. A is equal to 3, B is equal to 2, C is equal to 5, everything positive. So if I apply the quadratic formula, x equals parentheses, or not, fraction bar, plus or minus the square root, minus b goes here, 2a goes here, change a sign, double a number. B squared minus 4ac, our discriminant in this case, b squared is going to be positive 4 minus 4 times 3 times 5. That's going to be negative 60, so negative 56. Okay. Last step is to simplify as much as possible, and this is just simplifying a radical. First of all, there's a minus in the radical, that makes an I outside the radical, so that's fixed. When I see 56, 56 is 2 times 2 times 2 times 7. 2 times 2 is 4, times 2 is 8, times 7 is 56. A pair of 2's allows a 2 to be pulled out, so 2 times the square root of 14 is the same as the square root of 56. So again, simplifying radicals is a skill that you learned back in Algebra 1, maybe even before that. It's a skill you should have and be pretty comfortable with at this point, so I expect you to do it. Negative 2 plus or minus 2i times the square root of 14 all over 6. Since I have imaginary numbers, I'm going to split it apart into separate fractions, so both objects over 6. Reduce as much as possible. Negative 1/3 plus or minus the square root of 14 over 3i would be the end result I'm looking for. You can expect an imaginary answer on the test more than likely. Chances are this type of reduction will be possible. And again, I am expecting you to do it. If you stop here, I'll probably give you half credit. I think you're being a little bit lazy. If you don't even take the negative out and make it an I don't even give you credit for that at all. So a negative in the radical, make sure the I comes out. Not doing this much to get down to the most reduced form, I'll probably lose half credit because again, this is Algebra 1 level stuff. You're taking Algebra 2 tests, so I expect you to do that. Number 15, find C. First off, I can't find C unless I know what A is. I'm looking at A, I'm looking at a right triangle, so the Pythagorean theorem is alive and well in there. So A squared plus 8 squared is equal to 10 squared. So A squared is equal to 36, which means A is equal to plus or minus 6. But in the context of this problem, the positive answer makes sense, negative answers don't, so we just throw the negative answer out. Positive 6 is the only result for A that we would care about. And then if I look at the two triangles, the blue triangle, the small triangle, the red triangle, with dimensions of 15 for this side, 8 plus b for this side, and of course c for that side, are similar triangles because they both have a right angle down here in the corner. They both share this top angle, so that matches, so that in the blue and the red triangle is the same angle, which means this angle has to be the same as that angle. Looking at the blue triangle, I know that 6, 8, and 10 would all go on top. And I can see that in the red triangle, 6 corresponds to C, 8 corresponds to 8 plus B, and 10 corresponds to 15. This is irrelevant because I'm not asked to find B. So looking at these outside ones here, that proportion will allow me to find C. So if I cross multiply, 10 times C is equal to 6 times 15, so C is equal to 9. Again, you can't find C without A, but I don't have to find B to get the answer. So I'm able to do that without finding